Okay, for section 6.4, we're going to talk about sampling distributions of a sample proportion. Okay, yesterday we talked about a certain number within a sample. Today we're going to talk about a certain percentage or proportion. So we're going to it's very similar to yesterday's too. We're going to calculate the mean and standard deviation of a sample proportion and interpret the standard deviation. We're going to determine if it's approximately normal. And then if it is, we're going to find the probabilities. Very similar to what we did yesterday, just instead of the number, we're going to talk about the percentage or the proportion. Okay, so if you think about remembering what a sampling distribution is we take a sample. Okay, for example, this was about pennies, and the proportion of pennies were, I think, over a certain year or something like that. Okay. In the 2000s. Okay, so in the class here they took 20 pennies and they found the proportion that were in the 2000s. So this person had about 84% of the pennies that were in the 2000s. This person here had 80% of the 20 pennies in the 2000s. This person here had 80%. This person here had about 34% of the pennies that were in the 2000s. Okay, so this is our sampling distribution. Okay, now to find the center of this sampling distribution, if it's unbiased, we had said that the mean of this is equal to the proportion. So the mean of the sampling distribution, okay, the mean of the p-hats, all these are p-hats, right? All those are sample proportion, is equal to the true proportion of the whole population. Okay, and the standard deviation of all these p-hats is equal to the square root of p times 1 minus p divided by n. Okay, the square root of that whole thing. Those two formulas are what we're going to use for proportions. Okay, so when we're talking about proportions, this is the center of our distribution, and this is my standard deviation. Okay, so let's do an example. Okay, suppose that 43% of students in a large high school own a smartphone. 43%, that's our P, right? Okay, so our P, we know the whole population as this, but it's also going to be the same of our sampling distribution. Okay, so we know that the mean of all my p-hats is going to equal 0.43. As a part of the technology study, they survey 100 students. P-hat is the proportion of students in the sample who own a smartphone. So if you think about this graph right here, they do one survey of 100 students. This is the proportion who had a smartphone. They do another survey. This is the proportion of 100 students who had a smartphone. They did another survey. All right, they did a whole bunch of surveys on all possible samples. Okay, so we know that this is our mean, and our standard deviation of our p-hats is going to equal, the proportion was 0.43 times 1 minus 0.43 divided by 100 people in our survey. Okay, and if you work that out, it comes out to be 0.05. Okay, interpretation for that. When we take a sample of size 100, the sample proportion of students who own a smartphone typically varies by about this much from the mean. Okay, from the center of our distribution. Okay, if you think about what we did yesterday and today, really very similar. Okay, if you think about the number of pennies out of the 20 and then the proportion, right? That one out of 20 is that proportion. That one, right? 9 of them out of 20 is that proportion. 10 out of 20 is that proportion. Okay, so we have it. They're the same shapes basically. Okay, just different numbers on the bottom, because here we're talking about how many pennies. Here we're talking about the proportion of the pennies. Okay, now if we talk about shape, we had talked about it's the same thing as yesterday. We need to know that n times p and n times 1 minus p have to be greater than or equal to 10. Okay, So in this particular problem, to know if this is symmetric, we would take the 100 in our sample times our proportion, which would be 43, take 100 times 1 minus our proportion, which would be 57, therefore greater than or equal to 10. Therefore, we would say it's approximately normal. Okay, and then once it's approximately normal, if we wanted to, we could draw this out. We believe the center of our distribution is 0.43, the proportion, and it would have a standard deviation of 0.05. Okay, so our mean is 43%, standard deviation of 0.5. Okay, so let's do a problem here. A polling organization asked a simple random sample of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students attend college within 50 miles of home. Okay, so we have that about our population. Find the probability that the random sample of 1,500 students will give a result within 2 percentage points of its true value. Okay, so if we think about this, think about what's happening here. We ask all college students, right? We take it, there's 1,500 college students that we take a sample of, and those 1,500 will give us, do you live within 50 miles of home or not? It's either yes or no, and we know that 35% of them live within 50 miles. Now, every sample that we would get would be a little bit different. We might get a sample exactly at 35. We might get a sample a little less or a little more, right? So if we put all the samples together, our sampling distribution might look something like this. Okay, so let's go through the process here. To find the mean of our sampling distribution, it's going to equal the true mean, which was 35%. The standard deviation of this distribution will be the square root of n times p over n, right? So it's the square root of 0.35 times 1 minus 0.35 over 1,500, which gives us about 0.012. Okay? Now, shape, okay, we have to know if it's approximately normal. So n times p and n times 1 minus p here. N times p would be 1,500 times 35% would be 525. And 1,500 times 1 minus 0.35 or 65% would be 975. All are greater than or equal to 10. Therefore, we can say our shape is approximately normal. Okay, so if I draw this out, you know it's approximately normal with a center at 0.35 and a standard deviation of 0.012. Okay, so if you wanted to, you could actually add 0.012 a couple of times and subtract it a couple of times. Okay, but we want to know, let's answer the question now. So this is the third thing we want to talk about. What's the probability that it's going to be within 2 percentage points? So within this, so we want to know the probability that my x is between 2 points below that would be 33%, 2 points above it would be 37%. Okay, so I don't know where that is exactly, somewhere in here, right? So we want to know that probability between 33 and 37. Okay, so then we can go to Desmos and the normal distribution, put in our mean, which is 0.35, and our standard deviation of 0.012, check the box for cumulative, and our minimum would be 0.33, our maximum would be 0.37. And it should give you an answer that is about almost 90%, Yeah, let's say 90%. Okay, so there's a 90% chance that when I survey 1,500 people, that the percentage is going to come between 33 and 37%. Okay, one last problem for us. Potato chip producers and its main supplier agree that the shipment of potatoes must meet certain quality standards. If I'm making potato chips, I don't want rotten potatoes, right? So the producer finds convincing if they find convincing evidence that more than 8% of the potatoes have blemishes, the truck will be sent away, and they'll bring another load in. Otherwise, they'll take the entire load and make potato chips out of them. To make the decision, a supervisor will inspect a random sample of potatoes. Suppose the proportion of blemished potatoes is 8%. So we're going to assume it's 8%. And that the supervisor, they randomly select 500 potatoes. Okay, mean and standard deviation. Okay, so I know that my mean of the percentage is equal to the true mean here, which they give us is 8%. The standard deviation of those is equal to the square root of 0.08 times 1 minus 0.08 divided by, we're taking how many potatoes? 500 potatoes. Okay, so we got to work that out. Grab my calculator here. I hear my dog upstairs. And we get a standard deviation of 0.012. Okay. Next, we want to see, is it approximately normal? Okay, second step, n times p and n times 1 minus p. So 8% of 500 potatoes is 40 potatoes, and n is 500, right? 1 minus 8% would be 460 potatoes, okay? So they're both greater or equal to 10, therefore they are approximately normal. Okay, so I know that I have an approximate normal distribution shape. I know my mean is 8%, and our standard deviation is 0.012. Okay, so I have that distribution here, that shape. Okay, now let's find the probability that at least 11% are blemished, at least 11. So I want to know 11% or more. Okay, so if you go to Desmos, maybe I'll do that. Maybe I'll put that video in here. So I'll go to Desmos and put that video in here. Okay, so in Desmos here, we go to functions, go to distribution, and it's a normal distribution. We said that our mean was 0.08 with a standard deviation of 0.012. And we want to find the cumulative of 11% and more. So from 0.11 through infinity gives us a very small percentage, 0.6%. .006. So not a very high percentage of the time are we going to have potatoes, that 11% of the potatoes there. So this percentage we can see is very low. This, I didn't draw it very accurate, it'd be very small over here. Okay, but based on your answer, what should the supervisor conclude if he gets a sample of 500 and he does have something at 11%? Okay, so if he gets a sample at 11%, not very likely to happen. Therefore, he should reject the potatoes. Okay, so if 11% of them, it's probably not 8 or less. If it really is at 11, it gets a sample of 11.